The purpose of this video is to review worksheet 29. Everybody should already have the inequalities written for each problem because those were revealed in the Head Start video through Edpuzzle. This means it would be impossible to have a 0 on the assignment because you already have credit for 6 questions. Now that those are written, those would be the inequalities that get solved algebraically. For number 1, what's being done to the variable is adding 9. The inverse of that is subtracting 9. I'm going to write the original inequality, x plus 9 is greater than or equal to 150. I'll show the algebraic solving work on both sides. This isolates x on the left, and 150 minus 9 is 141. My solution is x is greater than or equal to 141. That inequality symbol would be represented by a closed circle on the number line and show values that are greater than 141, like 142, 143, and so on. When I check my inequality, I will write the original problem. I'm going to pick a number that is greater than or equal to 141. Personally, I'm choosing 142. Then I will simplify my inequality. 142 plus 9 is 151. My statement is 151 is greater than or equal to 150. That statement is true, which means I have chosen a true value for the solution to check with. Number 2, the inequality 3x is greater than 420. What's being done to the variable is multiplying by 3. The inverse of that would be dividing by 3. To solve, I will write the original inequality. I will divide by 3 on the left and divide by 3 on the right. This isolates the variable, and 420 divided by 3 is 140. I believe that my solution is x is greater than 140. The greater than symbol is represented with an open circle on a number line at that value and is shaded to the right to show values that are greater. When I check my work, I'll write the original inequality, substitute a value that is greater than 140, such as 141, and then simplify to see if I get a true statement. 3 times 141 is 423. And yes, that is greater than 420, which means that picking a solution greater than 140 was correct. For number 3, x over 5, or x divided by 5, is less than or equal to 200. What's being done is dividing x by 5. To undo that, the inverse is multiplying by 5. I'll write the original inequality, show multiplying by 5 on the left and multiplying by 5 on the right. Now the variable is isolated, and 200 times 5 is 1,000. X is less than or equal to 1,000. That symbol has a closed circle on a number line, and values less than go to the left, such as 999, 998, and so forth. When I choose a solution this time to check with, I'm going to select 995 because that is easily divisible by 5. And that would be 199 is less than or equal to 200, which is true. If you chose 999, for example, you would just get 199.8, and that is still less than 200. Problem number 4. The inequality is x minus 12 is less than 40. What's being done to x is subtracting 12. To undo that, add 12. The original inequality gets written down. then show adding 12 on the left, adding 12 on the right. This isolates the variable, and 40 plus 12 is 52. X is less than 52. Would be represented with an open circle and show values going less to the left. Then check a solution that is less than 52. I will be using 51. 51 minus 12 is 39, and then the statement is 39 is less than 40. That is true. That means I have chosen a true value less than 52 to check my solution. Number 5 is a two-step inequality. I don't see parentheses, I don't see exponents. I do see x being multiplied by 4, and also 15 is being added to it. When I undo, I will subtract 15 first, then divide by 4 using reverse order of operations. First, I'll show minus 15 on the left and minus 15 on the right. That would give me an equivalent problem of 4x is less than or equal to 12. Now, I'll divide by 4, and that gives me an equivalency of x is less than or equal to 3, and that's my solution. Less than or equal would mean a closed circle at 3 and values to the left, like 2, 1, 0, and so on. When I check my work, I'll write the original inequality, fill in a value that is less than or equal to 3. I'm just going to use 0. And then simplify the left-hand side, which has one more step now. 4 times 0 is 0, and 0 plus 15 is 15. 15 is less than or equal to 27. That is a true statement. For the final one, number 6, this is also a two-step 7th grade level inequality. No parentheses, no exponents. However, the x is being multiplied by 12, and also 40 is being added. The inverses would be dividing by 12 and subtracting 40 in reverse order of operations. First, subtract 40 from the left and from the right. This would leave 12x is greater than or equal to 108. Now, divide by 12 on the left and 12 on the right. This leaves x is greater than or equal to 9. That would be represented with a closed circle at 9 and shaded to the values that are greater than, such as 10, 11, 12, and so forth. I'm going to choose something a little ridiculous to check with because I never pick anything ridiculous. I'm going to pick 100. That is certainly greater than 9. Twelve times 100 is 1200. And 1200 plus 40 is 1240, which is most definitely greater than or equal to 148. For each problem, there is a check for the inequality, the do-undo, solving work, answer, solution, and checking. That's 6 different components times 6 different problems. There would be 36 things checked, and it will be a raw score part out of 36 as a percentage.